In this video, I'll explain about Euler's phi function. Euler's phi function, which is also called as Euler's totient function, is defined for positive integers. I will consider a positive integer which is named as n. Then Euler's phi function is denoted as phi of n. It is the number of positive integers less than or equal to n that are relatively prime to n. So, in other words, phi of n is the cardinality of this set. This set lists all positive integers which are less than or equal to n and relatively prime to n, meaning is GCD of k and n must be equal to 1. Then count how many such integers exist, that is called as phi of n. Let us take one example, phi of 9. Find phi of 9. First, let us find out the positive integers which are relatively prime to 9. So, GCD of 1, comma 9 is 1. GCD means greatest common divisor. 1 and 9 will have only 1 as the common divisor, hence, that itself is the greatest. The common divisors of 2 and 9. Divisors of 2 are 1 and 2. Divisors of 9 are 1, 3 and 9. Common divisors are 1. Only 1 exists. Hence, GCD of 2, comma 9 is 1. GCD of 4, comma 9 is also 1. GCD of 5, comma 9 is also 1. GCD of 7, comma 9 is 1. GCD of 8, comma 9 is 1. Therefore, now when you form a set of relatively prime integers to the given integer 9, then it is 1, 2, 4, 5, 7, 8. These integers are relatively prime to 9. So, how many are there? 1, 2, 3, 4, 5, 6. Therefore, phi of 9 equal to 6. It gives you the count, it gives you the number of positive integers which are relatively prime to the given positive integer. GCD of 11, comma 9 is also equal to 1, but that will not be listed here because the condition is all those positive integers less than or equal to n. 11 is greater than 9, hence that won't be counted. Similarly, phi of 5 equal to 4. For 1 is relatively prime to 5. GCD of 2, comma 5 is 1. GCD of 3, comma 5 is 1. GCD of 4, comma 5 equal to 1. GCD of 5, comma 5 is equal to 5. So it won't come under relatively prime. Therefore, 1, 2, 3, 4. These 4 integers are relatively prime to the given positive integer 5. Hence, phi of 5 equal to 4. Here there is a result which helps you to calculate the value of phi function for any positive integer n. So we know that any positive integer n is either prime or can be expressed as product of primes. That is by the fundamental theorem of arithmetic. So therefore, if n is a prime number, then Euler's phi function of n is given by n minus 1. There are n minus 1 positive integers which are relatively prime to n. If n is not a prime number, then it is composite. Then that composite number can be expressed as a product of primes in a unique way where individual primes are all distinct. So in that case, Euler's phi function is given as n into 1 minus 1 by p1 into 1 minus 1 by p2 into so on up to 1 minus 1 by pr. So this result helps you to find out Euler's phi function for any positive integer n. See, for example, I will consider n equal to 30. 13 is prime. Therefore, phi of 13 is equal to 13 minus 1, that is equal to 12. Means there are 12 positive integers which are relatively prime to the given positive integer 13. Now, similarly, if you want to find out Euler's phi function for n equal to 60, 60 is not prime. Therefore, you have to express this 60 as product of primes. Get the prime factorization of 60, that is 2 30s, then 2 15s, then 3 5s, then 5 1s. Therefore, n can be written as 2 to the power 2 into 3 to the power 1 into 5 to the power 1. Don't write 2 into 2 into 3 into 5 because each prime should be distinct. If there are repeated primes, then you have to write it in the index. So 2 to the power 2 into 3 to the power 1 into 5 to the power 1. So this is the prime factorization of given positive integer 60. Now phi of n is equal to, as per this formula, phi of 60 equal to 60 into 1 minus 1 by 2, that is the first prime, then 1 minus 1 by 3 into 1 minus 1 by 5, which is equal to 60 into 1 by 2 into 2 by 3 into 4 by 5. So simplify this, cancels, then 5 ones are 5 fours are 4 fours are 16. So there are 16 positive integers which are less than or equal to 60, which are relatively prime to 60. This is how we find Euler's phi function for any positive integer n.